Okay. Can you hear me?
Yes, we can hear you. Okay.
Great.
Yeah.
Thank you for the response. Good afternoon, everybody, and thank you all for being here today. It's an honor and pleasure for us to speak on the topic of critical computational literacy, ABC in CNC, especially in the context of Earth, nature, and society. A special thanks to Professor Ikeda for inviting us and to the organizer for this opportunity, to all of you for the time and attention. Computational literacy is more than technical skills. It is about critically engaging with the systems shaping our world. I look forward to exploring this together. So let's begin.
Good. Well, morning from Germany, or good afternoon to Kyoto. It's also a pleasure from my side to be at this conference and to give this lecture together with my esteemed colleague Juliane Engel. My name is Chris Burchard, and I'm the founding speaker of this C3S. We thought that we might start by briefly introducing what the center is about, and you will see that this links perfectly to the topic at hand. So to give you a very brief introduction, C3S was founded last year, and we are now in the process of hiring 12 new professorships across many disciplines, so coming from disciplines as diverse as economics, biology, geophysics, computer science, surveillance studies, to give you just a brief overview of what we have in mind. The C3S will be developed into a proper campus of critical computational studies in the near future. So we are now en route to renovate a prime property to then really bring these professors with staff and everything together on that campus. The very idea of the C3S, just maybe very linked to the conference that you're having, is to foster what we call cross-disciplinarity, and in this case to bring together the critical and the computational on equal footing. Now, cross-disciplinarity is a term that we use to span the breadth, if you will, of multidisciplinarity, interdisciplinarity, and transdisciplinarity, because we have the impression that these are important steps to take. So first of all, bringing people from different disciplines together to bring them into a conversation, which is maybe a multidisciplinary first step, then to truly link them together so that they do joint research on common topics, but then to also have insights from that interdisciplinary research bringing back to enrich their own disciplines. And in the final step, to then go to really venture forward to link these interdisciplinary research into a transdisciplinary endeavor. In our case, again, it's the idea of bringing two epistemes, if you will, together. That is the episteme of the computational, rather positivistic approach to the world, a approach which seeks to explain, with the critical, which maybe at least in the European continental development of modernity, developed into a episteme of its own to an extent, where we seek to understand and analyze more. So the computational, which is roughly speaking standing here as a synonym for computer science and science approaches, and the critical for social sciences and the humanities. You will see later that we have several permutations of how to bridge that, the critical and the computational in mind, but we'll list that concretely in an example. Now, since this is still a rather diverse set of research questions that pop up once you bring the critical and the computational together on equal footing, we focus on two areas of research to begin with. That is to establish and refine what we call a robust and justifiable methodology, hence where we develop methods, computational methods, but also then to reflect upon the implications for normative orders, political, scientific orders. In the first place, and in the second place, the second focal area would be what we call planetary transformations in Earth-nature society relations. Hence, how we can, on the one hand, by computational means, explore, explain, model transformations of planetary scale, but on the other hand, also to see how the digitalization or how the computational actually brings about planetary transformations with it. Since this is a research center with professors of its own in a university, a public university, we also have teaching and transfer not only obligations, but also, and even more so, the will to bring our research to students and citizens alike. And here we follow a critical computational literacy approach. Hence, we want to activate critical computational literacy as a transformative framework. So you see what we have in mind with the topic. We want to today span the planetary transformations in Earth-nature society relations and the teaching and transfer side of critical computational literacy. And this is where Juliane Engel will tell you a little bit more about in a minute on critical computational literacy. Now, on planetary transformations in Earth-nature society relations, that's again my turn to kick things off. Now, a first point that we would like to make is that we would like to frame these planetary transformations as an inequality crisis. But that is, of course, only one perspective to take, but it might be something that is particularly helpful to explain transformations, changes, whether they are going backwards or really bringing about a completely new era. That is something else to discuss. But these are transformations from a status quo that we see or that are seen today in society. Just to give you a couple of possible transformations that we have in mind that rather seem diverse, but that really come together once you bring on the lens of an inequality crisis is, of course, climate change, war and conflict, but also a very digital, if you will, affair that is the rise of large language models today. So the rise of AI and how it changes our epistemes of generating knowledge and working with knowledge. Climate change, of course, is something that is and that will be affecting, that is at least a very, very strong view, both in the science community, but also in the political community in Western Europe. We'll see planetary transformations. What I mean with that, or what we mean with that, is that we have here changes, climate change, that are not only, if you will, only of a geophysical affair, but there are also then very much affecting and are driven by ecological implications, the loss of biodiversity, for example, and then they are driven by, and they're again having consequences in society or socioeconomic, political, normative systems. Why an inequality crisis? Well, because as you can imagine, inequalities here on an ecological and biological side relate to the question of how the human or the humans are related to non-human agents, actors. Hence, biodiversity loss clearly insinuates a hierarchy driven by a perceived hierarchy, at least in a Western European modern style, between the human and the non-human. When we turn to other inequality crises, we see that the Western world, the minority world, is clearly driving climate change to the loss of actors in the majority world, hence in what was formerly called the Global South. So you see that planetary transformations with regard to climate change can easily be perceived as an inequality crisis. The same, I think, holds true to what could call a resurgence, a rise of a new era where war, violence, and conflict on a planetary scale are changing our global, in this case one could say global, world order. And to then bring it to even another level, the rise of large language models is something that will change, or seemingly is about to change, the way we do science, the way we do research in the humanities and the social sciences, the way we generate knowledge, the way we draw on knowledge past. And how is that an inequality crisis? Well, just to give a very brief example, the digital divide that is already prevalent in many of our societies, again, maybe Germany being a particular example, where there is always a certain hesitancy to embrace new technologies, maybe even a tech averseness being rather prevalent. This digital divide that we see today is exacerbated, made stronger by LL.Ms. For certain knowledge elites will have far better access and possibility to use those LL.Ms to their advantage, while those who are not in that camp might actually be lost on that way. So that would be our, if you will, internal society, internal inequality crisis, which might be exacerbated by the rise of LL.Ms. But if you look on a global or planetary scale, the differences between those who create these LL.Ms, especially in the United States, and the majority world are so strong that, again, the non-producing countries and societies, normative orders, are yet again to be possibly forgotten in the generation of these LL.Ms. That is why, to do a little bit of public relations, Juliane Engel and I, together with many other colleagues, especially from Brazil, with Cristina Godoy Bernardo de Oliveira being the lead author, have just published a policy brief for the G20, which convened in Rio, in Brazil, a couple of weeks ago. Why is that of concern from a point of view of critical computational studies, which seeks to bring together the computational and the critical? Now, because we feel and we fear that all of these planetary transformations has profound effect on the way we do democracy, on our democratic orders, and the aim hence has to be to make our democratic orders more resilient. So to really be able to accommodate these planetary transformations and to come to terms with them. For the matter of this conference, we feel, and that's what we do practice, and that's, or at least how we are now recruiting colleagues into C3S, is that planetary transformations in Earth-Nature Society relations really is something that calls for cross-disciplinary research. Again, multi-, inter-, and transdisciplinary research being called upon by this term, cross-disciplinarity. Now, and this is where we can draw on the three permutations of the C and C, of the critical and the computational. First of all, what we seek to do, and where we are currently hiring people to do that, is the computation of the critical. Again, that is, of course, a play with words or with concepts, but here we seek to truly approach critical transformations and critical points in the systems dynamics that we see on a planetary scale. Hence, a clear focus on tipping points, where are points in those transformations that when passed on a geophysical, biological, political, socioeconomic level, will bring about a future which we cannot then turn the wheel back from. In the Amazon case, for example, once the Amazon reaches a certain tipping point, it will turn into a savanna, and we will not be able to bring the rainforest back. The same, one could argue, might be happening on our normative systems. Once we ventured beyond a certain point, we will not be able to bring back, for example, liberal concepts of democracy, or old epistemes of knowledge generations once we very much are reliant, for example, on large language models and the way we do science. Now, that doesn't mean that those tipping points are per se negative or bad. In the case of the Amazon, I would say yes, with regard to the use of LL.Ms, that is open for discussion. But it is something that is important to have in mind when we, for example, then go into the transfer of our knowledge to policy actors and to see and to give advice of what to do to stall, mitigate, counter the reaching and overstepping of these tipping points. A second point where the computation of the critical really calls for cross-disciplinary knowledge is that we seek to couple, and I think that there is a strong need to couple models which operate traditionally speaking in different disciplines and based on different data sets, for example, to model how geophysical or Earth systems dynamics on a truly planetary scale interoperate with local dimensions of biodiversity loss in individual biomes, and how that is then related to the development of social systems. Hence, how is the melting of the ice caps in the Antarctica related to the transformation of the Amazon rainforest and the loss of that biome, which then has direct effects on the way we breathe in certain, whether there is sufficient breathable air in certain Brazilian cities. So here again, we need those coupling of geophysical, biological, and socioeconomic models and data sets. The critique of the computational, and I'm trying to be more brief, is, for example, calling on the use of smart cities to counter climate change, which, however, brings about the problem something which is very much feared in Western Europe and Germany, especially the rise of surveillance and how that could be exploited, for example, by authoritarian regimes. And finally, the computational critique approach would be really drawing on the data sets that I alluded to before to bring about how inequalities drive, for example, the rise of LLMs or of climate change. So these are the, if you will, permutation of the Cs and Cs and how those C and Cs really call for more cross-disciplinary research. And this is where finally we come to critical computational literacy and Juliane Engel's part.
Thank you so much. Yes, now we would like to turn our attention to the question of what mindset is required in times of planetary transformations and delve into critical computational literacy for Earth, nature, and society. This mindset recognizes that people are deeply entangled with the technologies that shape their surroundings. It calls for an approach that makes the entanglement accessible, bringing the implicit to the surface and making it more explicit. The calls for interdisciplinary research that focuses on coming to terms with planetary transformation and cross-disciplinarity. Such an approach seeks to connect the critical with the computational in ways that do not only reveal new spaces for innovation and design in the development and application of computational methods, but also make spaces for non-designability more visible and addressable. Our discourse analysis reveal that within the realm of qualification programs, we are still predominantly following an additive approach. In this model, computational skills are taught separately from complementary ethic training, often as distinct parallel components. However, this separation failed to address the deeper integration needed to navigate the complexities for today's digital landscape. This is where our concept of critical computational literacy come into play. CCL bridges the gap between the critical and the computational by intertwining these two areas in a way that fosters a more reflective approach to learning. It encourages individuals to critically engage with their own learning processes, cultivating a mindset of curiosity and openness, more than just a set of skills. This learning culture promotes digital participation by integrating the transformation of society, science, and technology with and through computational methods such as artificial intelligence. Rather than treating ethics as a standalone supplementary aspect, CCL weaves value-based thinking directly into the use of application of computational methods. This result is a value-oriented mindset, one that aligns everyday thinking, perceptions, and actions with fundamental ethical principles. By fostering this integration, CCL enables individuals to approach digital transformation with a sense of responsibility, ensuring that the tools and methods they use are shaped by and contributed to core societal values.
So what we came up with is to try to break what Juliane Engel just explained into a, if you will, simple image. And this is where we came up with what we call the ABC of CNC, the ABC of the critical and the computational being interwoven. Now, the A is something that stands for attitude or the mindset, as Juliane Engel was referring to. It calls on a mindset that is directing our modus operandi, the way we act, but not by a, if you will, explicit and reflective and conscious approach, but something that is implicit, that is socialized, that is internalized into, at some stage, even our way of being, our subjectivity. This is an important note making because it is something that we need to promote in order to really shape the way we do research, critical and computational, and then hence to address and come to terms with these planetary transformations. A digitized democracy, a democracy which, or democratic order, which might see major changes in weather patterns is something that we can only uphold in a democratic, and the Western European always has to add, liberal, freedom-oriented manner, when we have this idea that we are working with people, with citizens, which have internalized, subjectivized a critical and computational mindset or attitude. So that's the A. Just jumping to the C here, that is something which alludes to a capacity, or the capacities not only of individuals, but also of organizations and maybe even political orders, social and normative orders on a grand scale, to truly use implicitly and even more so now explicitly these methods, computational methods, in a reflected and proper manner. This might also require skills and competencies, but that is nothing that needs to be forgotten. To the contrary, but we need to establish capacities and do capacity building on a grand scale to enable all members of our communities across gender gaps and other gaps to interact properly with technology, for example, artificial intelligence. And this is something, and that's where the B comes in, the biographies, that really is to be looked on from the cradle to the grave. So from early childhood to old age, across biographies, we must not only focus on certain age cohorts, but we need to look again across lifespans to really foster attitudes and capacities that blend the C and the C and interweave the critical and the computational skills, but also critical reflective capacities. Now, once you bring that into practice, things get more difficult, and there's a couple of challenges, three of which I just mentioned. There is the question of how to bridge depth and breadth. Of course, you need to bring critical computational literacy to people that are already trained in the computer sciences depth differently than to people who are not adept in these technologies. And the same, but the reverse problem is that we need to have breadth. So it doesn't suffice that we only teach and school higher management of big tech companies. We also need to address our students, our citizens alike. So depth and breadth, how to combine that is a challenge. Scalability, to jump to the third bullet point, is that it doesn't suffice that we only teach very few individuals or organizations, but we need to have formats, innovative formats that allow us to truly be scalable and reach a grand number of people that can then act as multiplicators to establish a culture, as Juliane Engel was alluding to, of critical computational literacy, critical computational mindset that permeates societies, organizations alike.
And as Christoph pointed out, we are committed to developing CCL across all stages of life, recognizing that the need for digital literacy and critical engagement with computational tools is not limited to a specific age group or professional stage. Our approach spans from early education to schools and higher education at university and extends into the realm of professional training and ongoing adult education. By doing so, we aim to cultivate a lifelong learning culture that fosters the continuous development of these critical capacities. In our conceptualization of transformations through CCL, we take a holistic view, considering not only individuals, but also the organizations they are part of, as well as society at large. This means we understand that the successful integration of CCL requires a broad, systematic approach that engages multiple levels of society. We believe that fostering critical computational literacy is not just an individual endeavor, it is a collective one, involving educational institutions, workplaces, and the wider communities, the creation of more informed, reflective, and responsible digital society. Unfortunately, we can not delve into the specifics of each level at this moment, but we would like to emphasize that CCL we take as a holistic approach, considering individuals, organization, and society. This individual focus is essential because the empowerment of each person to critically engage with computational methods and technology is the foundation for broader societal transformation. Here are examples for CCL at the individual level. Immersive technologies such as virtual reality or augmented reality allow individuals to engage in realistic scenarios, providing an opportunity to identify and change implicit attitudes by reflecting on their actions and thought patterns. Similarly, AI-based assistant systems offered personalized feedback by analyzing individual behavior in real time, encouraging individuals to adapt and refine their thinking and actions. Additionally, gamified training programs use elements of gamification to make learning more engaging, helping to visualize both implicit and explicit transformations while motivating progress through reward systems. Together, these tools create dynamic, interactive environments that empower individuals to reflect, adapt, and grow. We envision the future of interdisciplinary research in the convergence of the critical and the computational. This basically means that we can and should ask ourselves what kind of society we live in and what types of societal models drive particular forms of change. Friederike Otto points out that societal models which exploit both people and nature are directly linked into the climate change currently being felt in numerous regions around the world.
So to wrap things up, I think it has become clear that we see the future of cross-disciplinary research in that combination of the critical and the computational. Of course, that is only one subset, and it is a subset that is particularly important for us because we have or are in the course of establishing that Center for Critical Computational Studies. But the idea, or the major idea here, is to truly go beyond that additive approach, to go beyond doing one and then doing the other, but to try to blend that together, to interweave it in the first place. This is something that needs time. It needs also a lot of resources on all parts of all participants, because it is essentially a means of breaking down our old epistemes. All the more so it's a worthwhile endeavor and an important one, because we have reached, or we are reaching now, a lot of problems, not of course all, but a lot of problems which we cannot holistically any longer approach from a monodimensional or monodisciplinary perspective. So bringing together perspectives in a multi, inter, and transdisciplinary manner, a cross-disciplinary manner, for us is an important means to address these huge crises that we might face, or that at least are perceived as being faced by societies today. It is a means to address planetary polycrises, and these planetary polycrises we would like to allude to by the idea of a planetary transformation going on that permeates not only one system, for example, the geosphere or the ecosphere or the social spheres, but that are really interrelated, so that the ecological, geological, and social are coming together. The Earth-Nature-Society relations in their interrelationality are the topic that we think call for cross-disciplinary research. So to boil it down, there is also, we hope, a bright future for cross-disciplinary research, but that doesn't mean that it will be an easy path. All the more so, we would be extremely happy to join forces and to share our experiences, also, of course, our setbacks and the challenges that arise once we bring researchers, societies from different perspectives together. And hence, we would be thrilled to explore how you actually, who are far deeper down that road of establishing cross-disciplinarity or interdisciplinarity in Japan, how you have covered these difficult steps. So we are here a lot for learning, and hence we are very much looking forward to any discussion, and hoping that the computer did as well. We would like to thank you and hope that that translation is actually the correct one. So thank you so much for your attention from Germany.
Thank you.
Thank you very much. So we will proceed to the question and answer. So is there anyone who wants to ask? Okay, Yamasuki sensei.
Can you hear us? Thank you very much for extremely interesting approach and also the challenge you are dealing with the most sophisticated computational technology. And bringing together from the Earth system to comprehend the Earth system and also the global change might be the very big challenge, because you really don't know what's going on, how the human impact is. That is one thing. However, at the same time, you have to optimize and also to predict the human behavior. How can we cope with the changing global environment? That is also another challenge. And of course, in traditionally, the physically based modeling and also the statistic based modeling was widely used in this field, and that required huge computational load. And I think the introduction by the AI and also the sophisticated technology may optimize and reduce the computational load, and also to reach the favorable answer, the possibility might be very increasing by adapting your concept. And that I agree. My question is it, I think even though it might be a very, very difficult task, because to provide the learning of the information, supervised information, you have to give a lot of information into the AI, because they don't know what is going on in the future. They may provide the wrong answer or wrong mechanism. And I think your challenge might be a very, very big, but if you can share how is the attempt and what is the success and what is the difficult part. And I think that you're doing a very big job, but if you can share us what is the most the practical difficult procedure and also the good point. Thank you.
Thank you so much for the question, an excellent one. I'll just give you some brief glimpses in what we are trying to do to address the issues, the important issues that you mentioned. So first of all, a couple of, I think the first solution to an extent is cooperation. We cannot do everything in our own small center to an extent. I mean, it's comparatively big, but if you look to the problems, it's tiny. So we are establishing research links to other major research institutions who are following similar path. For example, a new Max Planck Institute in Germany is also now approaching, they call it geoanthropology, from the idea of coupling different models, and they have their own IT departments to really come up with solutions of blending or coupling rather data sets. So cooperation also with the Potsdam Institute for Climate Research is, I think, the first answer. The second answer is that, of course, we have HPC resources of our own, not at our center, but at our university. So we are linked into major HPC facilities of Germany, the National HPC Initiative, and hence we have the if you will, thick data cables so that we can draw on that HPC. And the third and maybe most important answer is that that is this robust and justifiable methodology, which is especially robust. Robustness and justifiability insinuates sustainability. So that by bringing in experts for algorithm engineering and our colleague Ulrich Meyer, who is actually a specialist in optimizing algorithms, is unfortunately not present today in this talk, but that's the exact reason why we have expert in optimization of algorithms on board from the first place, so that we do not need to run too big training loads, that we can optimize the way we use HPC, the way we train these models from the first place. And this is again where that second focus on, if you will, the application planetary transformations, Earth, nature, society is linked to robust and justifiable, sustainable methods, method building that is interwoven from the very beginning, so as to address these issues that you rightly raised from the beginning, and not keep them apart in a different faculty or department, but to start building coupled models with a mind to making and doing that in a, if you will, doable way.
Then maybe I could add something. I liked your focus on the future, because for learning processes, it's a question, how do we imagine future? And how do we imagine in our models the human beings, the future, the nature, and so on? And that's why we combine the critical and the computational on an eye level, so that we are able to imagine different kinds of future for different kinds of societies. And that's very important for us. So thank you so much for this important question.
And maybe a final note, predictions are a tricky business, as you know better than I do. But maybe risk assessment is also an important ingredient. So not having, you know, the precise prediction, but to run many scenarios, so to get an idea of, you know, how more probable and less probable risks and non-risks that we face with regard to certain, of course, problems at hand. So this is also something that at least our researchers and PIs are looking into. So not so much the today's turn towards very concrete predictions, which might, you know, be wrong, because if we predict that the Amazon rainforest will collapse in 2 years, 3 days, and 5 minutes, that's a tricky thing. But to have a risk assessment then over the course of a certain period of time, something particular will happen, is easier to compute, and it is also, and more importantly, easier to communicate. Although it might not be as good for talk shows, but it's might be better from a policy advisory perspective.
Thank you so much. So interesting. So I have like kind of brief questions, 2 questions actually. The first one is like how generalized or like how robust this learning scheme is, like how this critical computational mindset can be adopted, for example, by like undeveloped country. For example, if they have like research institute, how costly that will be in that particular sense. For example, like if you want to adopt this learning scheme, you have to set up like all these, for example, LL.M modeling. You have to set up like HCP and stuff, and that will require high power supply, and also that will that will affect the same, like for example climate change and so on and so on, right? That is one question. The second question is like how this ABC thing quantitatively measured. In principle, the question might be like how this ABC answer this inequality crisis? Is there any successful case so far?
Juliane, do you want to start?
I could start. Thank you so much for this really excellent question. I think that learning always depends on experience. So everyone needs to make some experience, and then the implicit level of learning is touched and is transformed. So we need to develop formats, innovative formats that goes beyond the theoretical level of learning, that goes beyond the theories of planetary transformation. And I think that's very important to acknowledge different forms of knowledge. And that's how the inequality crisis comes in. So what kind of knowledge forms can we acknowledge, and how can we use them to develop computational method that goes on this experiential level and not just on a theoretical level? So we need more innovative formats that helps to develop an attitude, and that takes into account that we have very, very different biographies, and these biographies yeah, they build the way of how we learn. And so we need to investigate the biographies, and then we can try to develop innovative formats for the attitude level. And we have to do this together with our partners, not only in a Eurocentric way, but with our partners in Brasilia, in Kyoto, and so on, so that we have more possibilities to understand learning in a broader way.
Maybe also to add to that, so the question of scalability, I think, is what you addressed. So how do we scale solutions that we develop for country one, maybe a developed country as you called it, and then scale that question mark to scenarios or contexts that were not present in the initial development. So this is the scalability problem on several levels, including energy, but also others. And this is where we need, when we query whether we can just scale or need to profoundly adapt, that what we call a critical approach. For example, is it possible to use scenarios or formats that were developed for Germany, for example, to other Western countries with a different cultural backgrounds? Probably not, because the ethical and cultural contexts might be so different that it's not so easy to just scale and as a matter of just transfer. So you really need to have, in the initial development of these formats, someone involved who is then also able to see where we do the pivotal decisions to an extent, and they add up. So it's not only one decision and then you go a certain route. How these decisions actually affect, and how they are shaped by a cultural context, and how they re-affect that cultural context. So again, scalability is the issue. You were also, and that is then, of course, touching upon the problem of first of all, availability of data sets. So if you want to truly train models, retrain models, it's not only a matter of only in inverted commas of energy consumption. It is also a problem of, do you have sufficient data available, for example, to train a model that is then applicable to, I don't know, people in the Amazon rainforest, so rather undeveloped contexts, as you would say it, or to contexts which at least are not driven as much by the context of Western Europe or Western states. So this to get out of this developed undeveloped dichotomy, which is tricky at best. And then the second question you asked about measurement. Again, this is maybe we can do a second seminar on that. Measurement is an important ingredient, but it is also, of course, having pitfalls. And what we need to bring up is how to not only measure certain levels of skills and competencies, but to really have people experience certain mindsets or attitudes, and only once that is brought to the fore, we can actually hope to shape or to make more reflective that which drives us implicitly. But we're working together, for example, when it comes to measurement, with colleagues from a Leibniz Institute who is dedicated very much to that effect. So it's on our agenda, but we are still in the process of bringing that into the ABC scheme properly.
Is there any question? No? Okay.
So thank you for coming today, and I think we will finish the session. Thank you very much again, and okay. Thank you
Thank you
very
so
much.
much. Goodbye.
Bye.